All right, anything I say will now be recorded. All right. Okay, welcome to fall semester 2025 USC Suzanne Dworak-Peck School of Social Work's Research for Social Change seminar. It's great to have a live audience and an online audience. And if you're watching this after the fact, great to have you joining us asynchronously, so to speak. I'm Dr. Eric Rice. I'm the Associate Dean for Research here. And it is my pleasure to present a whole bunch of really fantastic topics this semester, starting off with today, which has got a great title, The Heaviest Data. Can AI Alleviate the Weight of Suicide Mortality Research, by my colleagues, Dr. John Blosnich and Dr. Swabha Swayamdipta. John is one of the faculty here at the School of Social Work, and Swabha is a faculty in the Viterbi School of Engineering in the Department of Computer Science. And with that, I will get out of the way and let them take it over.
Yeah, and thanks to Eric, because Eric was the matchmaker here who introduced me to Swabha when I was like, I have this massive amount of data I have no idea what to do with. And Eric's like, I know somebody. So that turned into this. So I'll start off, beyond this being a meeting of different fields, I'm gonna actually take this off with a art history lesson. So if there's art history people in the room or anywhere in the ether. So this is a picture, a painting by Titian, who was an Italian Renaissance painter, and it's of Sisyphus. So if people are familiar with the Greek the legend of Sisyphus, it's that his punishment was to roll this boulder up a mountain, only for it to always roll back down to the bottom of the mountain, and that was his punishment in the underworld. Not to say that research is punishment, but the word Sisyphus is often made into an adjective to describe an activity or a task that is very onerous, very difficult, and is also futile. I believe in one half of that, which is this task we're going to talk to you about today, is definitely difficult. I do not believe that it is futile. But when I thought about heaviest data, it just conjured this image of Titian for me, or the Titian's painting for me of Sisyphus, so that's why I used it. So anyway, that said, I'll end the art history lesson and move forward.
How do you spell his name?
Titian, Titian, I believe. I think that's like the anglicized version of his name. He's an Italian. Is it down? Oh, perfect. Starting out, we're going to be talking a lot about suicide. So I just want to make everyone aware of the National Crisis and Lifeline 988 as a touch point, cornerstone for this and everything else in your life, or people that you may encounter in your life who are in need of this service. It's 24/7. You can text, you can call. This research is supported by an award from NIMH, so I'm obligated to say that the opinions that we will express here are ours and do not necessarily represent the funder or the institution. So I'm going to do a typical quick grounding slide on suicide. So it's a major public health problem. Every 54 seconds, someone in the US is hospitalized due to a suicide attempt. Every year, there's about 50,000 people currently who die from suicide in the United States. These are numbers from 2023. I do a lot of work with mortality data, and it takes a while for us to get a settled data set for mortality because they're being reported in from all states and territories in the US. So there's a bit of a lag in how we learn about, how people died in the past year. In this case, 2023, we still haven't got, usually around December is whenever we get the reports for the year prior. So we should get preliminary numbers for 2024 coming up this December of 2025. And even then, they're still not fully settled until we're into 2026, basically. This is because for some manners of death, it can take a while for it to be actually ruled by a coroner or medical examiner. So if you have any other questions about death data, please come and see me. That's what I do all the time. Love to dim a room when I walk into it. And suicide deaths specifically are investigated by medical examiners and coroners. So the system that Swabha and I will be talking about today is a national violent death reporting system. But just know that all suicide deaths are investigated by coroner and medical examiner systems. While they both are systems that are devoted to getting information about how people die, one of the lead rules in the rule book of public health is the best way to keep people alive is to learn about what's killing them. These folks play a massive, crucial role in how we get mortality data that feed into this system. And so this system is MEDRS. So it is unique to the US. No other country on earth has a system like this. Some countries are trying to get this off the ground, but it's centered in the CDC for now. It started in 2003 with a handful of states. And so it was germinated by this idea that of all the biomedical infrastructure at the time that was going into promoting health and wellness in the United States, we were failing in terms of violent deaths. And so this was a way of trying to consolidate what information we could get. So it's taken about 20 years for this to become a nationwide system where full states are all reporting. And even now, it's not all states. So it's not all jurisdictions within a state. So California, for instance, I don't believe all counties are there, but California itself that now puts data into the National Violent Death Reporting System. So you can see here, it gets information about homicide, suicide, deaths involving law enforcement. So basically, deaths that require investigation are going to go into this system. And it is huge. There are this rolling stone of just massive amounts of narrative data around the circumstances around which people have died. And so how this information gets reported. So there are basically four main pieces of information that feed the MEDRS system: law enforcement reports, death certificates, ME, so medical examiner or coroner, MEC reports, and toxicology. Typically, toxicology is rolled in with the MEC reports. Now, all of that information gets distilled by a human being who is an abstractor. So that person is absolutely crucial to what gets put into this final system of the MEDRS. So MEDRS is composed of what we would call structured variables, which are numerically coded variables that people might be familiar with from like survey research, forced choice, like there's this question and there's this number that represents this answer. That's structured. And there's also unstructured data, which means there's just a quick narrative about what happened. So the MEC reports are typically gathered by either, medical examiners just typically don't go out and into the field. Coroners will do both. Medical examiners have death investigators that will go out and process evidence at the scene. They will handle the body. They will talk to next of kin or witnesses to get information about what happened in this circumstance. They will report all of that goes to the medical examiner for this final report that will go into MEDRS. So both structured and unstructured data. So I did some quick, so how many people are we actually talking about in the data set that we, so I did some quick calculations earlier. So we have cases, we have 270,000 cases from 2003 to I think 2019, Swabha, sorry. So 270,000, these are suicide deaths. This is not homicide. We have no homicide cases. 6,383 of these 270,000 have no narrative data whatsoever. So there's no law enforcement, no CME data, which sounds like a lot. 6,000 sounds like a lot, but we're talking 270,000 people. 44,000, almost 45,000 people have one narrative, and 219,000 people have both narratives. So you have to multiply that one by two because those are two narratives. So imagine having to read 483,199 narratives. Now, this is not a long narrative. This isn't like pages long. This is a paragraph, but this is a paragraph that weighs a ton because this is information about how someone died. There's a person behind this narrative, and there's a grieving family, friend base, someone who's been affected by that death also behind this narrative. So if a human was to undertake this task, and I could say handle reading 50 narratives a day, It would take me 9,664 days to read all of these narratives, so roughly 26 years to read through all these narratives. Not how I plan to spend the rest of my career. So just to give you a sense of just, I abbreviate it as hundreds of thousands, but that's just to give you a sense of what we're working with here and how long it would take you as a researcher to go through this. And even if I could read 50 of these narratives a day, they are sad, they are grim. I have sometimes cried reading some of these narratives. Others, it's taken me a while to take a swing around campus and walk around to try to clear my mind from what I read. These are really tough to read. Some of them are very, very tough to read. Death investigators, I mean, they are a special type of person who can do this job, and they will record what they see. And they will record the information as it lays before them. It doesn't mean it's what another person reading it can actually absorb to understand.
John, are they de-identified?
Yes. So they're de-identified. So I will say to access, that's an excellent question. Thank you, Dr. Aranda. The data are available for people to use. Clearly, we're using them. NVDRS and CDC have gone to great lengths to de-identify the narrative. So its victim is, and then they describe the circumstances. And you also sign an agreement with CDC that you are not going to try to re-identify anybody based on the circumstances you are reading. And there are severe penalties if they find out that you have violated that data use agreement. But anyway, all of that, the huge amount of data that we have, just the nature of that data, how heavy those data are, led us to this sort of, could this actually work? And I have that little llama down there for a reason, which Swabha can tell you more about. So I'll turn it over to Swabha.
Thanks, John, with that very, very necessary background on our project. I want to get to what we did using language models for this data. So, and it's so fun to see John using like language model emojis or like icons. Okay, so in the beginning, we told you that Eric did some matchmaking. So the way this started is, Eric connected me to John, and John was like, hey, you have been helping out Eric and others with some work on, homelessness. So I have this problem. Could you help us analyze some of these, like a lot of data that we have on these suicide reports to explore novel factors for designing suicide interventions or with aiding suicide prevention. So the specific research question we wanted to look at is, can language models assist experts in extracting new variables from NVDRS, which are not already encoded? So like John mentioned, there are already many variables in the order of hundreds of variables, which are already painfully extracted by these abstractors, these data abstractors, but we are limited to what they have already done. We cannot go about looking for new hypotheses from the existing data. So to give you an example, I cannot share the entire text, but a snippet in the text could indicate that the victim went through some family custody child support battle with her child, which is an indication that the victim interacted with a legal professional of some kind in the days before their death. And these are the interactions that we wanted to study. We wanted to extract these kinds of interactions from this unstructured narrative that is in the NVDRS reports to make this kind of a decision using a language model, whether there was no legal interaction that was reported in the narrative, or whether there was an explicit legal interaction where the report mentions the victim was scheduled to meet their lawyer, or the victim had met their lawyer in the week before their death. And in this case, we have an implied legal interaction, because when you're undergoing some kind of child support procedure, you are typically interacting with a legal professional. So the overall idea in this project was rather than having a human go painstakingly read all these reports, can we use AI or these language models to read these reports to extract this information, which could then help in designing new interventions for social workers who are working on this. So how do we typically use language models in social work annotation? In the few projects that have been done with language models, the standard way is to use a manual process for developing a code book, which I believe this audience might be familiar with code books.
Oh, yeah.
Right. So this is something I need to explain to the computer science audience, but yeah, you basically look at a bunch of narratives. You have an expert. In our case, the expert was John, and we had a couple of graduate students who were trained into understanding what we are looking for. So these were my students Jaspreet and a few other students in the team. And based on these interactions, based on John training, I was also part of the trained experts for a while. We read a bunch of these narratives to look for evidences of these kinds of implicit, explicit, or no interaction, specifically with legal personnel. So John has this wonderful, research agenda where he looks at many different axes for disruption for suicide prevention, where he is interested in looking at interactions between victims and a bunch of different non-clinical professionals. In our case, we decided to focus on legal professionals because it was the most clear-cut one. But even there were like lots of unknowns, because sometimes these victims themselves may be lawyers. So doing like a simple keyword search is not a good idea, because you might think that it mentions lawyer, but actually the victim was a lawyer, so that's not a real legal interaction. So we had to sit through a lot of this data, figure out corner cases. One very interesting case was the case of a DUI, where it is not very clear whether or not there would have been a legal interaction. John actually talked to a lawyer friend of his who helped us with these kinds of cases. So making this expert code book, which has these guidelines for what is considered an implicit interaction, what is considered an explicit interaction, this took a while to develop. But ultimately, we were able to collect 634 fully manually annotated narratives with these three labels, and we had a pretty reasonable inter-annotator agreement. But this was just for creating what we call a test set, where we can, if we are going to use language models to do this process, we want to show how well the language models will do on this test set. So then comes the part of, what do we do with the language model? So this was a fairly complicated pipeline, but I'll try to explain it as clearly as I can. So we started with, a very simple instruction that we gave to the language model. I'm guessing everyone is familiar with language models, ChatGPT. Yeah, and depending on who you are, you might have a very strong view on ChatGPT already. Oh, sorry, the text is a little small, so feel free to come closer if you want to read. So what's happening here? Maybe I can use. So what's happening here is we have the entire NBDRS corpus, which has about 270,000 narratives. From there, we sample some narratives. And we have to be smart here, because if we just take a random sample, we are most likely not to get any kind of legal interaction. So we had to look for some keywords or we had to do, a similarity-based search, but it's not just keywords. It had to be like a semantic similarity-based search because, attorney could be part of the narrative, or it could be like some other legal profession that we cannot enumerate, which could be part of the narrative. So we did a somewhat a simple semantic search here to get these sampled narratives. And based on the sampled narratives, we just asked the language model this instruction, which is identify whether the victim had an interaction with a legal professional, provide a reasoning and a label, which is implicit, explicit, or no interaction. And based on what the language model gave us, if it gave us the correct label based on, the expert's assessment, we would let that case go. But if it made a mistake, we would have the expert provide kind of guidance for the language model. Like, this is what you got wrong. And in the next time you see this example, this is how you correct it. So that's the expert guideline, which we provide when the language model gets something wrong. And based on these guidelines, we ask the language model another set of examples of reports and ask the language model for the same kind of labels along with the reason. And we keep on adding our instructions that we give to the language model with this expanded guidelines. So in the process of getting the language model to do the task, we are developing a code book, very similar to how a human-driven code book development process goes on, but it is iterative. So it's based on the mistakes the language model is making. And we continue doing this till we get to a point where either we have exceeded some kind of budget, which is the number of these reports that we want the experts to verify, or the model already does well, its performance exceeds some pre-specified limit. If I remember correctly, our limit was something like 0.8 F1 score. If the model exceeds that, we kind of we are satisfied with the process and we stop. So, and this is an iterative process, and I will tell you a little bit about how the iteration proceeds. But by the way, feel free to interrupt if you have any questions. There's a lot of information. Okay, so the good thing about this algorithm is that it sped up this completely manual annotation process from weeks to hours. So getting the left-hand side, the manual codebook development took us, I believe, somewhere around 2 to 3 months almost. Whereas if we were to do this exact same thing with the language model, for about 150 narratives, it took us 3 hours, which is a very big improvement. And once the model knows what to do, once we are satisfied with the model, now we can let the model make its predictions on the full data set. And that's the idea. On the entire 270,000 narratives, we want to do that. In computer science research, there is a big emphasis on the performance of the model. That is how accurately it made a decision. But one thing that is typically not considered is the amount of manual labor that is involved in this kind of annotation task. And in our research, we see that it's not just performance that we should care about, but this speed up as well that is important. And this is something that is important in language model evaluation. So language model evaluation is typically considered a very hard problem. Nobody really knows how to do it well. And we argue that looking at this kind of a speed up, how much manual emotional labor it is saving the humans it is trying to assist, could be a way in which we evaluate these tools. So this is a graph that tells you as the iteration proceeds, as we are iterating through our instructions from left to right on the x-axis, how the performance of the model changes. So as you can see, especially in the middle figure, there is a lot of variation in the beginning. So the model might get many examples right in the first round and many examples wrong in the second round. But towards the end of our iteration, the performance stabilizes and it gets to a place where we are satisfied with it or we exceed some kind of a budget.
What are the different lines? What's the light green line and the dark?
Yeah, so those are two different test sets we considered. One was a test set that we collected beforehand. The experts sat and gave us the labels for that test set, which I believe is the dark green line. And the light green line is the annotation set that we are building as well.
So this is one that you're using the AI, and it's the 150 in 3 hours as opposed to 600 in 3 months version.
Yeah,
Okay.
pretty much. Yeah, it was 3 hours.
Is the difference
Yeah.
between these lines meaningful? Or are they just two
Actually,
different lines?
no, I wouldn't say it is that meaningful. It's just two different test sets.
Okay,
And while the dark green line has 60 examples, and at the very end, the light green line has 150 examples. So it's not as meaningful. What we wanted to show is how the performance changes as we iterate
so
more.
no interaction, this dark green line that's staying pretty low, I shouldn't have any concern about that.
Because, yeah, no interaction is something that is not present in the way we sample these narratives. Because we want to have more evidence of like implicit or explicit.
Okay,
That's how we sample
Okay.
it. Because no interaction is kind of not as interesting to teach the language model something.
but one would assume you still have to be able to discriminate between
That's-
those that do and do not.
That's right, yeah. I mean, so what we primarily care about is the light green line. And for the light green line, you can see that overall, for all 3 cases, the performance increases. Because that's the one we will expand on.
Okay.
And this is a comparison of different language models. So what I've shown in 3 different graphs, I'm summarizing in one table here. So Llama, which is an open source language model that is considered one of the best open source models to date, has the best performance. So G0 is at the very beginning of our annotation. G25 is after 25 rounds of training the language model, and G-expert is what human performance is. So as you can see, after 25 rounds, the language model either matches or slightly is slightly worse than what, or slightly better than what the expert annotation is, which is great because it saved us a lot of time. With longer iterations, if you sit and teach a language model what to do, we get more stable predictions. And that is a very good sign of how we can help alleviate the burden of the abstractors for NVDRS. If you're wondering what happens in the entire corpus, this was just a very small sample. If you apply the language model that we trained as such to the entire corpus, what happens, like how prevalent are these legal interactions? We found that around 10% of 270,000 suicide narratives had some implicit or explicit evidence, or had some evidence of implicit or explicit legal interactions, which is a very big number. And this tells us that there is a lot of scope for doing suicide prevention research with legal professionals. So not only that, but it can also alleviate manual emotional labor in these kinds of heavy burden tasks. And this is my favorite quote from any collaborator ever. Is that, yeah, John said that our research was going at the pace of a bullock cart and we came at it with a jet plane. And I wish every collaborator of mine would say
John's got good lines.
There you go.
yeah, and it's very, very, very humbling to be doing this kind of research coming from a computer science background. Yeah, John talked a little bit about the data, and it is very, very challenging to look at the data. And to be fair, what we did with the language model is not extremely complicated. We didn't do something very fancy. We did a fairly, simple way in which we could, get this information from the language model. And turns out that even these kinds of very simple solutions can really, really help people in fields where there is not enough, support to carry out this kind of work. So that's very humbling, and like this is really inspiring for me. Like, there's a big moment right now happening in the field of artificial intelligence. It's everywhere, and yeah, it makes me think that this kind of work, if AI is applied in this kind of work, it is way more meaningful than like making the rich richer and like, building chatbots that can interact with teenagers and like have like, create like virtual lovers for teenagers. So that's like, yeah, the contrast is like really large and very cool. So one word of caution here is that we cannot just take these language models at face value. A lot of the reason for the success in this project was that we were babysitting the language model the entire time. And it is very, very important, especially when the language model is dealing with human data, to do that kind of very close monitoring, because it is very easy to do this work very, in a very non-careful manner, and that could lead to undesirable consequences. So we want to highlight that this is work that is done with human and AI collaboration, not just, letting the AI do whatever it wants to. And that's all I have. This is our paper, and if you're interested, you can take a look at the QR code. Thank you.
Thank you. So we have about 10 minutes for questions and conversation. Is there anyone who has?
I just want to say, I'm also very grateful for this. It's also very humbling for me too. I mean, I had to basically put my butter churn and abacus away because I'm definitely in the Luddite camp when it comes to any sort of like AI stuff. It took us, I think our first year was just basically finding a way to talk across like data, and then me thinking like, oh, well, just make this llama thing do this. And so I was like, so it doesn't like, it kind of doesn't work like that. And I'm like, oh. So yeah, I think the first couple meetings or months in this collaboration was just learning about what basically we both do.
Yeah, each other's language, yes, absolutely.
Go ahead.
Well, thank you both for this really invigorating presentation. I've learned a lot. I'm wondering, one of the aims that you had at the beginning of the presentation was how this method could assist in the development of suicide intervention. I'm sure prevention. How do you see something like this kind of leading you into that area of intervention research in this area?
Yeah, so and Swabha kind of hinted at this, and I did a very bad job of putting this table setting in front of everyone at the beginning. So this is part of a project that we've developed over the years. More was back there, could do this much better, but it's around this concept of industries of disruption. So it's engaging non-clinical spaces where you could find somebody who works a lot with a person who's probably experiencing a lot of distress. Right now, a lot of suicide prevention is focused on behavioral health centers, places, clinics, hospitals, absolutely necessary and important and life-saving. Unfortunately, most people don't survive to get there. So we're building my opinion is if we're building these places to get people to, it's not a Field of Dreams sort of 80s movie reference, everyone. If you build it, they will come. A lot of people do not. And as we kind of learn more about, and we're able to learn more about people within their moments of distress, a lot of people send the absolute opposite signal that they're in distress to everybody around them, to many people around them. So one of the ways that this project is trying to forge our path into non-clinical spaces to bolster prevention is basically demonstrating that these non-clinical partners are actually having a really tough time. Some of them recognize it, some of them do not. But from a mental health research and suicide prevention research realm, it's really been so squarely put into the real estate of psychology and psychiatry that we don't see anything else, right? In my opinion, is we rarely see other places. So, you know, other research we've done with attorneys have shown that upwards of 4 in 10 of them have had a client die from suicide. So they're highly impacted by suicide loss, but they have zero training in mental health. And I think both sides have not been able to kind of see this demonstrated of how prevalently this comes up, and that while we are also focusing on behavioral health, we should also be devoting some resources and thinking about what does this look like in the family law space and mediation spaces and in legal arenas. Criminal law is a little bit further along in this. They've wrestled with issues called custodial death, so people who have died while they were within law enforcement settings. So that may come to a finer point, but we're hoping with this that we could show a broader swath. And that prevention point, Dr. Ronda is a great point, because at that point, it's sort of like, well, we need to hear from this community. What will they bear? Because their industries are not around mental health and suicide prevention. My industry as a family law attorney is to get you a divorce and to get you the best settlement possible or to get the best outcome for you possible. My first priority is probably not, in my mind, not going to be your mental health. It's this thing in front of you. How do we get that both and without these industries shying away from, don't train me to be a therapist. I don't want to be a therapist. I'm not a mental health person. What do I do when this comes up? What do you want me to do when this comes up? And we have to hear from them because they will lean back out, is what my experience has been with working with these different industries.
Thank you.
Yeah.
I know we've got, Mike has raised his hand. Is there anyone online that would like to ask a question? If so, raise your hand and you can be the next person up. But in the meantime, Mike, go ahead.
I'm sure there are other things you're trying to code besides just the law. Is this sort of a proof of concept that, and it allows you to feel comfortable moving on to other things that you might code?
Yeah.
Is that the basic idea? And I don't need a long answer there. If the answer is yes, I'll ask a separate question. Okay. Then my other question is one of, because I think about like these language models and basically we're feeding in a lot of information. And do the rules allow for this kind of data set to be fed into these models? Are there any ethical issues around feeding 200,000 personal narratives?
Great question. So for this research and for all research in this domain, we do the feeding in just locally. So we download a copy of the language model and all the development happens locally. Nothing is going back to language model builders.
Does it take specialized expertise to bring the language model down locally? Like, is it helpful to have someone like you who knows how to, like, or could I do that relatively easily with my butter churn next to me on my side?
I think it is possible for people without a computer science background to do it locally. Eventually, our goal is to build like algorithms that we use to train the language model locally. That will need a little more like a computer science background, perhaps. But for this project, we didn't do anything fancy. We were just prompting the language model.
So let me just give a specific example. Like if we want to do something with our own learning experience, evaluations from our classes, could we bring a language model down locally and ask some questions related to that and not have anything feed into anywhere else, just so that we could use the data for ourselves?
Absolutely.
Okay.
And you can do that. Yeah, there is I can talk to you offline, but there are tools where you can install it on your laptop,
Okay.
have it give you answers. It might not be the best language model, but it will.
Probably that's what we need to do.
Yeah.
You should have safeguards.
Right, because you
I
don't
mean,
want to
it's
use,
still
you don't want to
public.
use the commercially available version of, say, like ChatGPT, where the default is that anything you enter in is then uploaded into the ChatGPT, corpus, and so this is something that would not be a HIPAA compliant way of going about things, or it would probably violate your,
Yeah, your agreement.
your data use agreement with NVDRS, and so it's a great point, sorry.
I'm just curious, I don't know a lot about, I don't know anything about how you kind of developed or like started to kind of identify some of this information through the LLM, but I'm curious now that you have kind of done it for one variable, is the process for identifying information for other variables the same? So would it require, again, like manual coding to use like as the basis of the code? Okay.
Yeah, so here I only presented this legal interaction case, but in our paper, we show this for many different variables. Some of which are already coded in NVDRS, but we just wanted to validate that our language model algorithm works for those variables as well. So yeah, it is generalizable. Great question.
All right, and let me know, so your cost will be more, right? Because
Somebody's got an echo effect. Okay,
Okay.
go ahead, Nick.
I'm just curious, thinking about something like this long term. I think with qualitative data, part of the process is just being fully in the data itself to sort of contextualize it for yourself. So like with the class evaluations as an example, I would imagine you wouldn't just want like the takeaways, you would want to kind of be in it throughout. So I guess I'm curious, when you think about this long term, how, since there was obviously such a process in the beginning with the kind of like human development piece, what it would look like to use an LLM without that human development piece in the beginning.
Yeah.
Yeah.
Yeah, I think in our experience, like just feeding in the language model, just this instruction to do this task doesn't work too well, because the language model makes a lot of mistakes. It doesn't have as much of like a background in, like, let's say social work in this case, or suicide prevention research. And even if it did, there would be, like, ideally, this is like the language model should assist the expert and not just take over. That's like, and we have empirical evidence for the fact that this collaboration works much better than the language model doing this on its own. So that's what we advocate for. Now, having said that, the fact that anyone can use these language models means that people will be doing what you're saying, like letting the language model do what it wants to, and that can be tricky. But as far as we're concerned, we strongly advocate for human AI collaboration.
Fantastic. We're at 12:45, so I think I just want to.
E had a question.
Oh,
One
Shani's
question.
got a question. It's got to be fast. Go for it.
Yes, this is a technical question. So how much annotation is needed for the amount of data you're coding? Or is there a saturation that you can reach by some standards?
Yeah, so we used around 150 different reports, annotations on 150 reports for getting to a certain level of performance that we were satisfied with. But this is something, again, it depends on the use case, it depends on what the user wants. If you have like a very, very high bar, you want to do this for longer. If you're okay with, if the stakes are not as high, maybe using fewer examples works. So that's something like that we have left as a design question.
So it's more like iterative process, right? Because I assume the coding is also a development process. So if you use the coding to verify, but you are actually changing the coding, similar in the manual process, that probably takes some iterations.
Yeah.
Yes, unfortunately, Shinyi, your audio is echoing crazily through the room and it's hard to understand what you're saying. Not any reflection on your comment, but just the audio interface, our technology has failed us. We need an AI to fix our audio settings automatically so that you don't get an echo. But I think I'm sure that Swabha would be more than happy to answer some more of these technical questions about iterations offline. I would like us just to thank our presenters again for a wonderful talk. And please join us next week and every week this semester, as we will have a wonderful set of presentations, including Dr. Shinyi Wu next week, if I remember correctly. So Shinyi, you can be here in person and share your work with us next week. So thanks, everybody.
Cheers.
Yeah, I definitely did this morning. It was like,